Hey everyone, my name is Julian Miller, and in this video we're going to cover the importance of destructors. You should all be familiar with dynamically allocated arrays and what's going on here. We're declaring an array of size 5, and then generally you're going to want to loop through the array and do something with each element, and after we're done, you want to make sure you clean up the dynamically allocated memory. I'm showing you this because I think it'd be easier to first explain why we need destructors before I describe what they actually are. So we're going to take some of this functionality and encapsulate it inside of a custom array class. Our array is going to have a size, and it's also going to have a pointer to some dynamically allocated memory to hold our elements. And both of these are going to be private. Next, we'll make the constructor for our array, and it'll take in a size, and I think that'll be it. Then we want to allocate the memory for our elements in the constructor as well. I'm also going to go ahead and add something to let us know when our constructor is called. Next, we're going to give it a method to get the size. And we're also going to give it a method to access the elements. C++ has a neat feature called operator overloading, and we're going to use that here. And basically what that does is it lets us use the square brackets to index our custom array just like a normal array. Now let's change our main function to use our new class. So we'll instantiate an array of size 5, and here we can use array.getSize. And because we're overloading this array subscript operator here, we can access our custom array just as if it were a normal array. So we'll just go through the elements and we'll set them to I times I. We'll also get rid of this delete statement. And we'll add a bit of output just to make sure things are working properly. And we'll run it and see what happens. Awesome. So we're creating our array of size 5, and then we are looping through each of our elements and printing them out. But there's a problem here. We're making a new memory allocation, but we're not deleting it anywhere. It'd be nice if we could delete it somehow automatically when we don't need it anymore. And it's this type of logic that we can put in a destructor. A destructor is similar to the constructor, except it has a tilde in front of it. And instead of being called when we instantiate the object, it gets called when we destroy the object. So let's try deleting the allocated memory in here. And we'll also put some output. Keep in mind that you never have to explicitly call the destructor. It'll get called automatically for you. So let's take a look at when this actually happens. So we're going to have some output as soon as main starts. We're also going to take this and put it at the end of our main function. And if we run it, you'll see something interesting. Our array is constructed right after main starts, which is what we expect. Then it goes through and prints the elements of the array, and main ends. Then you'll see the output from our destructor. So our destructor is called automatically when our array variable goes out of scope, which is when the main function ends. The scope of a variable is limited by curly braces. So if we added curly braces around here, you should now see that our array variable is destroyed as soon as it leaves this area here. And you'll notice our destructor is called before main ends now. And this is the case wherever there's curly braces. So in if statements, or while loops, or for loops, and even function calls. Another case where the destructor is called is when we delete an object. So let's say we were dynamically allocating our array and calling delete on it here. Our destructor would also be called here. There is a special case you have to be careful of though, and that's with polymorphism. Let's say we wanted to extend our array class. So our subclass isn't going to do anything different. We're just using this as an example. And if we go and set the dynamic type of our array to a special array, and fix these problems here, you'll notice that our subclass's destructor isn't called. So this is a problem. If we had some sort of other memory allocated in our subclass, it wouldn't get deleted. The fix for this is actually pretty easy. All we need to do is set our subclass's destructor to virtual. And now you can see that our subclass's destructor is being called as well. So if you're making use of polymorphism, make sure your destructor is virtual. And that's all there really is to it. As always, let me know if you have any questions, suggestions, or comments, and thanks for watching.